This is section 4.1, inverse functions. And we're going to begin with identifying one-to-one functions. And a one-to-one function is a function if for A and B in the domain of f, if A is equal to B, then f of A does not equal f of B. In other words, if the y values are the same, the x values need to be the same. Okay, so let's take a look at this. Determine if the relation defines y as a one-to-one function of x. So as you can see here, we have the same y value, but we have different x values. So in this case, it is not a one-to-one function, okay? And we can use this notation one-to-one, okay? So basically, we want no repeated x or y values, okay? And that comes from first being a function and second being one-to-one. So now we have Batman to Joker, Green Lantern to Sinestro, and Wolverine to Sabretooth. So yes, this is a one-to-one function. Now, if a function is one-to-one, no horizontal line intersects the graph in more than one place. So as you can see, we can draw horizontal lines, and you can draw them anywhere. And the line only hits the graph one time, and in this case, points. So yes, we have a one-to-one function. Now, as you can see, this single horizontal line, this intersects the graph in many different places. So this is not one-to-one. Okay, and looking at number 5, if we're careful, we can see 1 point, 1 point, 1 point. So any horizontal line that you might draw will only hit the graph one time. So yes, we have a one-to-one function. Now we're going to actually use the definition of a one-to-one function to determine whether the function is one-to-one or not. So here we'll show that if f of A equals f of B, then it must be that A equals B. So let's go ahead and set f of A equal to f of B. And f of A is 3A plus 2, and f of B is 3B plus 2. We'll go ahead and subtract 2 from both sides. And we have 3A is equal to 3B, and we'll divide both sides by 3. And as you can see, we have A is equal to B. Therefore, yes, we have a one-to-one function. Looking at number 7, we want to check f of A equals f of B and see if A equals B. So f of A is 3A squared, and f of B is 3B squared. We'll divide both sides by 3, and we'll have A squared equals B squared. And now if we take the square root, we get A equals plus or minus B. So A is not exactly equal to B, so we have no, not one-to-one. Okay, now let's talk about inverse functions. And here we will determine whether two functions are inverses. So we will use the composite function f composed with g of x and also g composed with f of x. And we want to make sure both of those are equal to x for all x in the domain. So given a function f of x and f inverse, we will imply that f composed with its inverse is x and vice versa. So in number 8, we'll determine whether the two functions are inverses of each other. So we're given f of x and g of x. So let's go ahead and find f composed with g of x first. That's defined as f of g of x. And that's equal to f of 1/3 x minus 2. And that's equal to 3 times 1/3 x minus 2 plus 6. And that's x minus 6 plus 6, and we come up with x. Now we will try g composed with f of x. So now we have g composed with f of x, and we have g of 3x plus 6, 1/3, 3x plus 6. Don't forget that minus 2. And you can see that is equal to x. So therefore, yes, we have inverses of each other. Okay, looking at number 9. We have f and g given. We'll try f composed with g of x, and that's f of 5x plus 1, and that's 5x plus 1 plus 1 divided by 5, and we get 5x plus 2 over 5. And that's definitely not equal to x. So we're actually finished here, but let's go ahead and try g composed with f of x. And that is g of x plus 1 over 5. And that's equal to 5 times x plus 1 over 5 plus 1. And that's x plus 1 plus 1, and that's equal to x plus 2, and that's definitely not equal to x. So we can say that no, f and g are not inverses. Okay, now let's see how we can be given a function and find the inverse of that function. Okay, so we have a few steps here. The first one, if they give you a function, if you're given a function that uses the notation f of x, first replace f of x with y. You may be able to skip that step. Then we will interchange x and y, and then we will solve for y. And whatever you get for y, that will be equal to f inverse of x. Okay, so let's go ahead and begin with this first one. we'll let f of x equal y. We will interchange x and y. And now we're going to solve for y. So we're going to multiply everything by 2. And we have 2x equals 4 plus y. And we get y equal to 2x minus 4. So therefore, f inverse of x is equal to 2x minus 4. Now, we can check this. We can find f composed with g of x, that's f of 2x minus 4, and that's 2 plus 1/2 times 2x minus 4, and that's 2 plus x minus 2, and we have just x. Now, let's try g composed with f of x. And we have g of 2 plus 1/2 x, and that's 2 times 2 plus 1/2 x minus 4, and that's 4 plus x minus 4, and yes, that's equal to x. And now you can see that this is f of x, and we can graph 2x minus 4, and it looks like this. And that is equal to f inverse of x. Okay. Let's take a look at number 11. This is a rational function. Please make sure that you practice this. Okay, so we have f of x equals 3x divided by x plus 1. We'll replace f of x with y, and now we will interchange our x and our y values. We'll multiply both sides by y plus 1, distribute the x, and now remember that we're solving for y. So we are going to now have to make sure that the terms with a y in it are on the same side of the graph. So we'll have x equals 3y minus xy, and factoring that y out, we have 3 minus x. So y is equal to x divided by 3 minus x. Therefore, f inverse of x is x divided by 3 minus x. And I think I will go ahead and square this one off up here as opposed to using the highlighter. Okay. And as you can see, this graph is f of x. And now if we graph this f inverse of x, you can see that we have a vertical asymptote at x equal to 3. And the graph actually looks something like this. And this is f inverse of x. Okay, we can check that. Let's first check f composed with f inverse of x, and that's f of x divided by 3 minus x. And actually up here, I called g f inverse. So I should probably have clarified that that is f inverse. Here I'll use the notation. And that's equal to 3 times x divided by 3 minus x all over x plus 1. We'll multiply the numerator and the denominator by 3 minus x. I'm going to rewrite this. So we have 3 times x divided by 3 minus x all over x plus 1. So now we'll multiply the numerator and the denominator by 3 minus x, and we'll have 3x divided by x plus 1 multiplied by, I think here I need to replace that x with x divided by 3 minus x. And now you can really see that complex fraction. So we're going to have 3x divided by x plus 1 times 3 minus x. That's a little better. That's equal to 3x divided by x plus 3 minus x. And as you can see, that's 3x divided by 3, and that's equal to x. Okay, so now we can check f inverse composed with f of x. And that's equal to f inverse of 3x divided by x plus 1. Okay, and that's equal to x, which is 3x divided by x plus 1, all divided by 3 minus 3x over x plus 1. Now we'll multiply the numerator and denominator by x plus 1. And as you can see, we'll have 3x divided by 3 times x plus 1 minus 3x. And that's equal to 3x divided by 3 and that's equal to x. We don't have to check these every time, but I think it's very good practice. Okay, and now let's go ahead and look at number 12. And in number 12, we have f of x equals x squared plus 3. And in this case, we're only taking the right half of this parabola. So this is f of x. And we just want that right half. Okay, so now let's go ahead and see what we have. We are going to let f of x equal y. Then we're going to interchange x and y. And now we have y equals plus or minus root x minus 3. But as you can see, here we only want the positive x values. So this is actually going to be just the positive y values, okay? So this is positive x values for x implies positive y values for f inverse. So we only want that positive root. Okay? So now what we have is, let's see, let's check this. Let's try f composed with f inverse of x, and that is f of root x minus 3, and that's equal to root x minus 3 squared plus 3. And as you can see, that's just equal to x. Okay, and let's go ahead and graph this x minus 3 with the root. As you can see, we'll begin here at 3, and the graph will look like this. And this is f inverse of x. Okay, how about f inverse composed with f of x? Whoops. That's f inverse of x squared plus 3. And that's the square root of x squared plus 3 minus 3. And that's the square root of x squared. And that's actually equal to x, where x is greater than or equal to 0. Okay, let's take a look at this last problem when we're given coordinates of f. So this is the graph of f of x. So our points on f of x, and let's just go through them one by one. We have 1, 4. We have negative 1, 2. That was negative 1, 2. And then we have negative 3, 1. And negative 4, negative 2. Now what happens? F inverse interchanges the x and y values. So if we plot these for 1, 2, negative 1, 1, negative 3, and negative 2, negative 4, and we connect these, we now have a graph of f inverse of x. And that concludes this section.